This video continues reviewing the arguments of the Pandas read CSV function. In this video, I will specifically discuss the various options available to you for reading in and manipulating NaN values in your favor. On the screen, you can see the very simple CSV that I will be working with. It contains 3 columns, the first a collection of names, the second a set of numbers, and the third a set of letters. You'll notice a few things about it. There is a designation no letter for 2 of the values in the letter column. There is also one misplaced in the numbers column. There is a no number in the numbers column for Steve. There is a blank in the number column for Ed, and a none in the letter column for Susan. All of these instances could be considered NaN values in a data frame. I would like to show you how to make Pandas read this in such a way that you have complete control of how it reads NaN values in your CSVs. Moving over to my Jupyter notebook, you can see I am using Pandas version 2.0.3, so it is the latest version as of December 2023, the time of this recording. I am also importing read CSV directly from the Pandas library as well. First, let's just bring in the CSV to show the data. Here we have our 3 columns and 6 rows. You'll already notice that Pandas is reading in the empty cell as NaN and the none as NaN. This is the default behavior for read CSV. The 4 arguments that we will be covering, which you can see at the bottom left-hand corner of the screen, are NA values, keep default NA, NA filter, and verbose. Let's start with NA values. NA values specifies what values in the data frame should be considered as NaN, in addition to the ones that it already defaults to NaN, such as the blank cell and the none, as we have already witnessed. NA values can take a single value, a list, or a dictionary as an argument. First, let's try a single value. Here you can see that I read in the CSV and state that the string no letter should also be considered NaN. Executing this, you can see that all 3 instances of no letter are converted to NaN, in addition to the ones that we already saw converted. Let's get rid of that no number as well by using a list. You can see that by passing a list to NA values, the appropriate output happens and no letter and no number are now NaN. Now what if we only wanted to affect 1 column of values? Let's say we want to keep the no letter in the number column for John for whatever reason. To convert only 1 column of values to NaN, you can pass NA values a dictionary. My dictionary has the column letter as the key and the specific values that should be converted as a list of strings, specifically in this case, no letter. Here we see each instance of no letter turns into NaN, but the one in the number column remains. Now let's move to the next function, keep default NA. Keep default NA has a default value of true. There is a collection of default values in Pandas backend that it knows it needs to transform to NaN values. So when it's set to true, it transforms anything in that collection to NaN. That collection is seen right here in their documentation. You'll recognize various forms of n/a and null, to name a few, which Pandas performs this specific conversion on. To reverse that behavior, simply assign keep default NA to false. You can see below that there is no transformation happening anymore. Even the initial empty cell and the none are not getting transformed to NaN. That's because it's ignoring the conversion to the default values it has stored behind the scenes. There is some customizability to this. Let's combine this argument and the previous one. If you want to still overwrite some values to be NaN, but don't want anything else converted, you can supply those specific ones to the NA values argument. You can see that keep default NA is not affecting the empty cell or the none string, but no letter from the letter column has been successfully converted to NaN. Using these 2 arguments allows for vast flexibility in how you want to handle NaN values when reading your CSV into memory. The next argument is NaFilter. Its functionality is very similar to keep default NA equals false. It prevents the conversion to NaN. However, it stops any conversions at all. Let's try adding the NA values argument just like we did with the previous code block. Executing this, you can still see that we have the no letter text in the letter column. So NaFilter stops any conversion at all from happening. But keep default NA only stops the conversions to the values Pandas has behind the scenes. Pandas website states that using NaFilter on large files can improve the performance when reading, likely because it's not going through the whole file with the purpose of transforming any values to NaN. The final argument we have here is verbose. Executing this cell, you can see some additional text is supplied. Verbose adds information about the read, specifically tokenization, type conversion, and memory cleanup. Tokenization involves breaking down the input text from the CSV file into individual tokens, which are just basically the smallest units of the text. After the tokenization happens, the parser converts the tokenized values to appropriate data types. And then, as part of the memory cleanup, it releases and cleans up memory resources used during the parsing process. The Pandas website states that this argument also supplies information about how many NA values are placed on non-numeric columns. But I haven't been able to produce such output with any combinations of supplied arguments that you have seen demonstrated so far. So that really concludes the deep dive of each of these 4 arguments that really help you manipulate and control how NaN values are being displayed in your data frame. To sum each one up, NA values specifies what values in the data frame should be considered NaN. Keep default NA specifies if the data frame should contain NaN values based upon the collection of values Pandas has behind the scenes. NaFilter prevents any conversion to NaN at all. And verbose supplies additional information about the read. As always, thank you for watching this video. I hope it was informative. I have a handful more of these read CSV videos coming out pretty soon. Let me know in the comments if this was useful. Please give it a thumbs up so that other people can see it. And don't forget to hit subscribe so that you know when the next video releases.